So for sine, cosecant, cosine, and secant, I want you to write plus 2k pi. And then for tangent and its reciprocal, which is cotangent, I want you to write k pi. This is when no interval is given. And I'll explain what I mean by that in 1 second. But the first thing you need to look at is if an interval is given or not, okay? We are solving trig equations today. It's just like your basic algebra. But there is a difference. If they tell you that you're looking at something for answers only over the interval of 0 to 2 pi, that just means one trip around the unit circle, so you don't have to put plus anything at the end. If they don't give you that interval restriction, then you have to put, if it's sine, cosecant, cosine, or secant, plus 2k pi at the end of your answers, because it could be one time around the unit circle, it could be 12 times around the unit circle. If it's tangent or cotangent, it's k pi, okay? What I mean by that, guys, look at number 1. Look at number 1. All right, I'm going to make this even bigger so you can see it. Do you see how it says solve 2 sine of x minus 1 equals 0? Everybody see that? All right, so the first thing I want you to do is you're going to isolate the trig function. Here's your trig function, sine of x. It's not just x. We want to isolate the whole trig function. Everybody with me? So to get sine of x by itself, what's the first thing I would do? I'd add 1 to both sides. So I have 2 times the sine of x equals 1. And then what? Divide by 2. So I have sine x equals 1/2. Now, talking about stuff on the unit circle, remind me again. If I have an ordered pair, x and y, what is sine? What value?
Y.
Sine is the y. What is x? Cosine. And then tangent is? Good. Tangent's y over x. So what this is saying is they're saying go to the unit circle and find all the what values? Sine is what? Y values. So find all the values on the unit circle where y is 1/2. So go to your unit circle and tell me where all the places the y value is 1/2. Pi over 6 and 5 pi over 6. Agreed? It's not 7 pi over 6. Why? Because that's negative. So your answers here, guys, would be x equals, would you tell me? Pi over 6? Okay, so pi over 6 and x equals 5 pi over 6. Now, did they give you a specific interval that you're looking at? No. So then what do I have to put at the end since I'm talking about sine? 2k pi. And then up here I put 2k pi. That means it can go 10 times around the unit circle, 20 times around the unit circle, something like that. All we're doing today, guys, is solving basic equations, some quadratic, and you're using the unit circle to find your answers. This should make a lot more sense than everything else that we've done because it's not as abstract. We good? We okay? All right, look at the next one, example 2. Read it. Find all the solutions, blah, 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 over the interval of 0 to 2 pi. That means I'm only talking about one trip around the unit circle. So do I have to put plus anything at the end? No. So if I have this equation, sine of x plus root 2 equals negative sine of x. Guys, if this was just a normal problem, it said x plus root 2 equals negative x. You want all of your x's on one side. I want all of my sine of x's on one side. There's a couple ways you can do this. What can I do? Okay, I can move negative sine to the left and root 2 to the right. What else could I do? Can I just move the sine of x to the right-hand side? All right, I'm going to do that because it's less steps. So I'm going to subtract sine of x, subtract the sine of x. So I have square root of 2 equals what? Negative 2 sine of x's, correct? So now, how do I get sine of x? Whoops, I didn't mean to erase it. How do I get sine of x all by itself? Divide by negative 2. So divide by negative 2. Divide by negative 2. So I have sine x equals negative root 2 over 2. All right. What does that mean? How do I find out what x equals? I go to the unit circle and I look for what? I want y values. On the unit circle, what y values are negative root 2 over 2? So let's go and look. Where's my y? Negative root 2 over 2. 5 pi over 4 and 7 pi over 4. So you guys would write x equals 5 pi over 4 and x equals 7 pi over 4. Do I need to write anything at the end? Why? Because they gave me the specific interval. Good. This is not horrible. We're using all of our algebra skills. We're using some trig stuff. We're using all sorts of stuff that we've learned this year and in previous years to solve these. But does that make sense? Everybody okay? Yes? Okay. Next page. What do you notice about this problem? It's tangent. It's squared. Good. What about, is there a given interval? No. So then at some point I'm going to have to add what at the end of my answers?
2k.
Not 2. No. Just k pi. Tangent and cotangent are different. So guys, look. Let's solve this like we would a basic algebra problem. I want to get this tangent squared of x all by itself. So what am I going to do? I'm going to add 1. So I have 3 tangent squared x equals 1. Then what? Divide by 3. So I have tangent squared of x equals 1/3. Now what do you think we do? Take the square root. Perfect. If I put the square root on, what is my answer? If I put the square root on, what goes in front of my answer, guys? Plus or minus. What is the square root of 1? 1. What's the square root of 3? Do we know? Okay. Can I leave this like this? What do I do? Rationalize. So I'm looking for all the places on the unit circle that the tangent is positive or negative root 3 over 3. This is where you got to think a little bit. Okay, look at your unit circle. Tangent, guys, remind yourself, tangent is what? Y over x. So let's think about our unit circle. Let's just look in quadrant 1. There are only 2 possibilities for tangent in the first quadrant and all the way around. That's going to give us either root 3 or root 3 over 3. We do tangent, right? What's the tangent right here at pi over 4? Tangent's 1. Everybody remember that? Because it's y over x, root 2 over 2 divided by root 2 over 2. So one of these ordered pairs is going to give me root 3, and one of them is going to give me root 3 over 3. If you guys could memorize this, it'd make your life a little easier, but if you can't, you just have to do the work. So if I look at this top ordered pair, tangent is root 3 over 2 divided by 1/2, correct? You guys agree? Yeah. So it's root 3 over 2 times 2 over 1. So I get what? Root 3. Good. So when my x value is 1/2, the tangent's going to be root 3. When my x value is root 3 over 2, what's my tangent value going to be? Okay, if we can't answer that question, let's work it out. 1/2 divided by root 3 over 2. I keep change flip, yes? So I get 1 over root 3. So what's the tangent at this pair, at ordered pair? Root 3 over 3. Now you guys could memorize that if you want to. At root 3 over 2, 1/2, my tangent is root 3 over 3. At negative root 3 over 2, 1/2, what's the tangent? Negative root 3 over 3. At negative root 3 over 2, negative 1/2, what's my tangent? Positive root 3 over 3. At positive root 3 over 2, negative 1/2, what's my tangent? What is it? Negative root 3 over 3. So we're looking for all the possibilities, those 4 places where I get negative root 3 over 3. What are the 4 answers that we just circled? 5 over 6. What else? 5 pi over 6. I'm just going to go around the unit circle. 7 pi over 6. And 11 pi over 6. Now, since this is all tangent, what do we write at the end of each answer? K pi. Now, this only happens in tangent, and I'll show you why in a second. With all of our other functions, sine, cosine, and their reciprocals, we added 2k pi, which is one whole circle, correct? Well, in tangent, you only add a half a circle. So what do you guys notice? If I start at pi over 6 and I add a half a circle, so I start here and I add 1/2 of a circle, where do I end up? At what?
Another tangent.
Another tangent. But what is that value you see? 7 pi over 6. So do you guys agree with me that these two are redundant? They're the same answer.
Yeah.
So I would cross this one off. Same thing here. I go to positive 5 pi over 6. If I add pi, I get to where? 11 pi over 6. Are these two redundant?
Yeah.
Yes. It is technically wrong if you answer a tangent question and have all 4 answers. I'm telling you guys, write all 4 like that, and then give me 1 positive, 1 negative. Do you see how pi over 6 is going to give me a positive tangent? And 5 pi over 6 is going to give me a negative? I would just keep these 2. But I would write all 4 down. Just make sure that you give me 2 that are not the same thing. If you gave me pi over 6 and 7 pi over 6, you're not giving me 2 different answers. You guys see that? You're giving me the same answer, just in different quadrant. So just be mindful of that. If you write all 4, I'm not going to give you full credit. If you cross them off like you should, that sort of thing, that's fine. If you only write 2 of them, then it's the correct, then that's cool. I don't care. But you guys have to be mindful of that. I would try and get this tangent stuff memorized so you don't have to do the extra tangent work at the end. All right, look at this problem. Look at 4. We got to solve. I have a cotangent, a cosecant squared, and a 2 cotangent x. There's nothing really we can do here. We can't, if you divide one side by cotangent and the other side, it's not going to really help out much. So when you have a factoring problem, you know it's factoring because there's a what?
Cot.
No. What makes this, oh shoot, I might have to factor it. This because the second power is 2 different kinds of stuff, second power. So let's just move this cotangent over here. So I'm going to rewrite this as cotangent of x times cosine squared of x. Whoops. I always forget the last letter. Minus 2 cotangent of x equals 0. Where did I get the minus? Because it's positive and I moved it over. How come I can't just say, well, the cotangent in the first term minus 2 cotangent? Because it's multiplied. This is together. This is one term, so you can't just subtract a cotangent from it. So now, guys, let's think back to algebra. I told you, every time you have a factoring problem with trig, this is probably the hardest kind of problem we're going to do. What does each term, this is a term, and this is a term. What does each term have in common? They both have a cotangent, right? So if I take the cotangent out and I put it in front, I'm dividing it out. If I divide out cotangent from both of these, what am I left with in the first term? Cosine squared of x. And what am I left in the second term? Minus 2 equals 0. Agreed? Now, we're factoring. We're making smaller. When I factor a problem and I get x times x minus 3 equals 0, what do? How do I solve this? I say x equals 0, x minus 3 equals 0, and I solve, right? Yeah? We're going to do the same thing here. I'm going to just write cotangent of x equals 0. And over here I'm going to write cosine squared of x minus 2 equals 0. Just 2 different problems. So now we got to think. We have to trig. We got to think trig. Cotangent. Remind me what cotangent is? What over what? No. X, Y, whatever. Talking about ordered pairs. It's what? It's x over y. In order for the cotangent to be 0, what number has to be 0 in this fraction? The x, right? This has to be 0. So you're going to go to the unit circle, and you're going to look for all of the x values that are what? That are 0. So go to your unit circle. Where are my x values 0? Pi over 2 and 3 pi over 2. So I'm going to say, okay, x equals pi over 2 and x equals 3 pi over 2. Now, this is what kind of a problem? Which trig function? Cotangent. That means what do I add at the end? Plus k pi. So think about this, guys. What do we have to check when we have tangent or cotangent? If I look at my unit circle, if I'm at pi over 2 and I add half to it, if I add half a circle, what do I end up at? 3 pi over 2, the same thing, right? So do I need both of these answers? No. Now I go over to cosine. Solve this like you would a normal algebra problem. What do I do first? Add 2 to both sides. So cosine squared of x equals 2. How do I get just cosine? Square root. So I'm going to go to the unit circle and look for what values? Cosine is x values. Where on the unit circle, guys, are all the cosine values root 2? None. Does that exist? Is root 2 over 2 the same as root 2? No. So here, you would say, doesn't exist. No solution. Can't do it. Cross it out. Whatever. Let me know that you understand, though there's no possibility for that. And that's okay. There's only about 5 different answers you're going to be able to look for, guys. Think about the unit circle. You can have positive or negative 1/2, root 2 over 2, root 3 over 2, or our tangents, root 3 over 3, or just root 3. And then excluding, obviously, our quadrant angles of 90, 270, 180, and 0. That's probably the hardest kind of problem that we're going to do, in my opinion. All right, we're good? All right, let's go. Find all the solutions over what? 0 to 2 pi. That means I do not what? I don't add anything at the end. I don't have to. You're telling me it's just one trip around the unit circle. So, guys, we've already done a problem like this. 2 sine squared of x minus sine of x minus 1 equals 0. What kind of a problem is this? It's a factoring problem. I'm going to rewrite it as a normal factoring problem. 2x squared minus x minus 1 equals 0. You don't have to do that. I just like to do that so I can see it a lot easier. How do we factor 2x squared minus x minus 1? Okay, multiply the 2 and the negative 1. So I get negative 2. What are the factors of negative 2 that multiply to give me negative 2, but add to give me negative 1? X minus 2, x plus 1. Now I cannot just leave it like that because my a term is not 1, remember? So what do I do with the a term? Divide both bottoms by 2. Perfect. So I'm left with x minus 1, agreed? Equals 0. And then what's my second parenthesis look like? 2x plus 1 equals 0. Now we're talking about trig. So what do I replace the x's with? Sine. So this is really sine x minus 1 equals 0. And 2 sine x plus 1 equals 0. Solve the one on the left. What do I do? What?
Add 1.
Add 1. Perfect. So sine x equals 1. Add the one. Do the one on the right. Minus 1. Yes. 2 sine x equals negative 1. Divide by 2. So sine x equals negative 1/2. So what you just did was you told yourself where to look at what? The unit circle. What values am I going to look at for? Why? How come why? Because it's sine. So on the unit circle, I need all the y values that are positive 1 and negative 1/2. So let's go and look. Where is y positive 1?
On
Pi over 2. Anywhere else? No? Okay, where is y negative 1/2? Yep.
7 pi over 6. 11 pi over 6.
So we have 3 answers. What do they happen to be? Pi over 2. You can write it like this if you want to. 7 pi over 6 and 11 pi over 6. What do I not have to write at the end? The plus 2k pi. How come?
He's already had it.
Because they told me over a specific interval. Is this terribly difficult? No. Is it a lot to remember and look at? Yes. But you guys are doing good. 2 more, and then we're done. Okay, this is similar, but it's a tad different. How is this a little different? There's more stuff in it. Okay, what do you mean by more stuff? I agree. There's 2 different trig functions, yes? Okay, there's a plus 3 and a minus 3, good. But the big difference is I have sine squared and I have cosine. We have a way to get these all to be the same. Whatever the middle term is what you want to convert to. That's a good little thing to remember. I have an identity that says sine squared of x plus cosine squared of x equals what number? 1. All right, if I want everything in terms of cosine, how can I change sine squared into cosine? Okay, if I move this to this side, would you guys agree that I can replace the sine squared of x with 1 minus cosine squared x? Yes?
Yes.
That's what we're going to do. Whatever the middle one is what you want. Whatever the middle trig function is what you want to change to. So this, I'm going to rewrite it as 2 times 1 minus cosine squared x plus 3 cosine of x minus 3 equals 0. Now we just go back to algebra. What do I have to do with that 2? I got to multiply. I have to distribute it in here. So I have 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. You guys see anything that anything has in common? What can I do with the 2 and the negative 3? I can combine like terms. So I'm left with negative 2 cosine squared x plus 3 cosine x, what? Minus 1 equals 0. Do I have all the same trig functions? Is this now just a factoring problem? All right, I'm going to rewrite it algebraically so I can see it better. This is the same as negative 2x squared plus 3x minus 1 equals 0, right? Can I factor? Yes, leading with a negative. Do I want to? So what am I going to do? Not yet. I don't want to. I don't like to factor when my first coefficient's negative. I don't want to distribute it. I want to take it out. I'm going to take out that negative 1. So it becomes 2x squared minus 3x plus 1 equals 0. Now that we've taken it out, we've changed all the signs behind, we don't need it anymore. It's done. It's gone. So now factor. You guys are going to tell me 2 times 1, right? 2 times 1 is 2. What are the factors of positive 2? That multiply to give me positive 2, but add to give me negative 3. Minus 2 minus 1. Agreed? All right, my a term is not 1, so divide. So I'm left with x minus 1 and 2x minus 1. Now, we started off with cosines, right? We started to factor. So what am I going to change my x's to? So I'm going to write cosine x minus 1 equals 0. 2 cosine x minus 1 equals 0. And now we just solve like normal. What do I do to both sides? add 1. So I'm looking for cosine of x equal to 1. Here, I'm going to add 1, right? 2 cosine x equals 1. Divide by 2. Cosine x equals 1/2. Did they give me a specific interval? Nope, that means I'm going to have to add 1 at the end. 2k pi. But the only thing I look at right now on the unit circle is what values? I want x values. Why am I looking at x values? Because it's cosine. So go to your unit circle and tell me where all of the x values are 1 and 1/2. So where are my x's 1? That's 0. All right, where are my x values 1/2? Pi over 3? 5 pi over 3. So we have 3 answers. We have x equals, you could say 0 plus 2k pi. Could you also put 2 pi? 0, 2 pi, same thing. I can say x equals pi over 3 plus 2k pi. And I have x equals 5 pi over 3 plus 2k pi. Long problem. Am I going to give you 20 of those on your test? No. But I understand it's a long problem. You guys did great. One more and I'm done. Did I say long problem? I know. All right, let's last one. Last thing we're going to look at. How is this problem? I'm going to rewrite it because I don't like t's. How is this one different from the other ones that we've done? There's one major difference. Anybody notice? There's a number where? Before the x, okay? This is called a multiple angle problem. So look, I still want to isolate my trig function, right? So how would I do that? Add 1 to both sides. 2 cosine 3x equals 1. Then what? Divide by 2. So we're still using the exact same thing we used to do. There's just one little difference, and we're not even going to see the difference yet. Cosine is what values? X values. So I go to my unit circle where all my x values positive 1/2. Pi over 3 and 5 pi over 3. Okay. Now, here's the difference with the multiple angles. Every single time I wrote my answer, I wrote x equals. Is that the case here? No. What am I going to write? I'm going to write 3x equals. It's one little extra step to solving. So you're going to have 3x equals, what did we say, pi over 3? And then we have 3x equals 5 pi over 3, right? Guys, how do you get x all by itself? Divide by 3. When I divide by 3, I'm dividing by 3 over 1, right? So we keep, change, flip. What's my answer? Pi over 9. Here, same thing, divide by 3. So I divide by 3 over 1. I'm going to keep, change, flip. What's my answer? And I look, just check. Did they give me a specific interval? No, we're talking about cosine, correct? So what do I put at the end? Perfect. Very good. So the multiple angles is just one extra step at the end. Instead of saying x equals, you have to just put whatever the number is. If it said 1/3 x, instead of dividing both of them by both sides by 3, you would do what? Multiply both sides by 3. That's it. That is it. All right. Are we okay? All right, this weekend, you guys have a web assign that's due Tuesday. Then you have a test review that's due Wednesday. So let's look at that.